This video is the 26th and final lesson in the Hands-on Equations learning system. And in this lesson, I'm going to show you the standard written notation that you will use to solve equations once you are taking an algebra course. At the top of the screen, I've written out an example equation, and on the left-hand side of the screen, you'll see what the pictorial solution might look like. We have our initial setup, then we took away 4 from each side of the equation. We took away 2 x's from each side of the equation. We ended up with 2 x's is 16, and if 2 x's is 16, x then must be equal to 8. The written notation in algebra is a little bit different. The first thing you do is you start with just the regular equation. Then when you want to show that you're taking 4 away from each side, we simply write a minus 4 underneath the numbers from both sides. We will continue to write an equal sign and bring that down all the way as we're working this out. And the reason we do that is just to show that our equations remain balanced even when we take something away from both sides. What we take away, subtracting 4, is the same on both sides of the equal sign. So now that we've done that, we're left with 4x on the left-hand side and 2x plus 16 on the right-hand side. You'll see that that's exactly the same as what we have right over here. We have 4x and 2x plus 16. When we're ready to take away 2 x's from both sides, we just subtract 2 x's underneath each of the x's. Keep bringing down our equal sign. Do that subtraction and we're left with 2 x's equals 16, which makes x equal 8. When you're performing your check in the standard written notation in algebra, you perform your check within the problem at the very top. So if x equals 8, we're going to do 4 times 8. That's what 4x means, is 4 of the x's, 4 times 8. That would be 32 plus 4. And on the right-hand side, we have 2 x's, 2 8s, which is 16 plus 20. So that gives us 36 on the left and 36 on the right. Here's another example, and when you're first starting out with these, I recommend that you do a pictorial version and a written version, just so you can get a better view of what you're doing, and you can kind of help connect the written version to your pictures. So I'm going to continue doing that. On the left-hand side, here's our pictorial setup. We have 3 x's, another x, and a 2. And on the right-hand side, we have 3 x's, and then we're taking away an x, and then we're adding a 16. So the written notation for algebra would be 3x plus 2 equals 3x minus x plus 16. But with the algebra version, we're going to combine like terms before we move on to the next step. So 3x plus x is the same thing as 4x plus 2, and 3x minus x is the same thing as 2x, and then plus 16. And you'll notice that that really is the same thing as what we have on the left-hand side, 4x and 2, 2x and 16. My next step is going to remove 2 from both sides. So I'm going to show that in the pictorial method that I'm removing 2 from both sides. And that will become 14. And in the written method, I'm going to subtract 2 from both the numbers. So I'm left with 4x equals 2x plus 14. My next step in pictorial will be to remove 2 x's from both sides. So I'm going to show that, 2 x's from both sides. And do the same thing on the right-hand side, 2 x's from both sides. That leaves me with 2x equals 14. And I can see that over here, 2x is 14. If 2x is 14, x is equal to 7. And I'm going to do the check just on the right-hand side. Go back to the original equation. We have 3 times x, 3x, which is 3 times 7, 21, plus another 7. That gives us 28, plus 2. That gives us altogether 30 on the left-hand side. And on the right-hand side, we have 21 minus 7, which is 14, plus 16 more, which is also 30. So our check, 30 equals 30. Here's another example, and for the pictorial method, this is the distributive property, so I have 2 of everything that is in the parentheses. So I have 2x plus 3 twice. So 2x and a 3. And I need to do that again. I'm just going to stack it right on top of it. 2x and a 3. And then I have one more x. And on the right-hand side, 2x and a 12. For the written notation, we're going to rewrite the equation. And then we're going to simplify the expressions and combine like terms. And what I mean by that is we're going to use the distributive property here. So we have 4x plus 2 times 3, which is 6, plus x. And now we're going to simplify, which means we're going to combine like terms. We have a 4x right here, and then another x on the same side, and we can combine those. So that gives us 5x plus 6 on the left-hand side, and 2x plus 12 on the right-hand side. And again, we can see that that's really the same thing as over here. We have 5x's plus 6 and 2x's plus 12. My next step on the left-hand side is I'm going to remove 6 from both sides. Let me combine these x's, and then I'm just going to combine the 2 3's into 6. I'm going to remove 6 from both sides. So the 12 is going to become a 6 right here. You're going to subtract 6 from both sides in the algebra way of writing things. So I'm left with 5x on the left and 2x plus 6 on the right. Again, you can see that that's the same as what we have on the left. And next, I'm going to subtract 2 x's from both sides. So these 2 are going to go away, and these 2 are going to go away. I'm going to do that same thing over here, subtract 2 x's. I'm left with 3 x's on the left and a 6 on the right. You can see that that's the same thing as what we have on the left-hand side. And if 3x equals 6, x equals 2. For our check, in parentheses, we have 2x, that means 2 times 2, which is 4, plus 3 more, which is 7. But we want 2 times that, so 2 times 7 is 14, plus 1 more x, which is 2. So altogether we have 16 on the left, and then on the right, we have 2x, 2 times 2 is 4. 4 plus 12 is 16 on the right, so our check, 16 equals 16. It gets a little bit more complicated when we start using negative x's or the stars. So let me write an example that uses those. And again, the pictorial method, we have 4 x's, and then we have 2 of the negative x's or 2 of the stars, and then a 3, and we have an x and a 5. And for the algebra method, I'm going to rewrite the equation. And I'm going to simplify any expressions and combine like terms. Like terms is I have 4 x's and then 2 negative x's. Well, when I combine 4 x's with 2 negative x's, I'm only left with 2 x's. So I'm going to go ahead and combine those. And here is my new equation. Now notice that what we're doing right there is we actually just skipped a step that what we did over here, because in order to get this equation from this, we actually have to do one more step where we remove 0 pairs. Squeeze my 3 in over there, because this would be my next step, is I'd remove these 2 0 pairs, and then I would be left with 2x plus 3 equals x plus 5. My next step after that with the pictorial method would be to take the 3 away from both sides, which would leave me with 2 on the right-hand side. So subtract 3 from both sides. We're left with 2x equals x plus 2, because 5 minus 3 is 2. And the next step I'd do in the pictorial method would be to take an x away from both sides. Do that for the algebra version. We're left with just one x on the left-hand side and a 2 on the right-hand side, so obviously x equals 2. For the check, up at the very top, we have 4 times x, or 4 times 2, that's 8. Then we have 2 of the negative x. Well, negative x would be the opposite of x. So I have 2 groups of negative 2, which would be negative 4. So I'm going to add negative 4. So 8 plus negative 4, that will give me positive 4. And positive 4 plus 3 gives me altogether 7. And then on the right-hand side, we have 2 plus 5, which is also 7. So 7 equals 7. Here's another example, this time with subtraction. So setting up our pictorial method, we have 4 x's. And then we're going to subtract 2 negative x's, but I don't have 2 negative x's to take away. So I'm going to have to add a 0 pair. So here are my 2 negative x's. They're paired with 2 positive x's. And now I can take that 0 pair, or take those 2 negative x's away. And then I have plus negative 2. On the other side, we have 2 negative x's. And we're subtracting 18. I don't have 18. So again, I'm going to have to add a 0 pair. So a positive and a negative. We're then taking away the positive. On the right-hand side with the algebra version, we are trying to take away 2 negative x's. And of course, we can't do that. So in order for us to take away 2 negative x's, we're going to have to add a 0 pair, just like what we did on the left-hand side. So when we're adding a 0 pair, we're going to add 2 x's, and we're going to add 2 negative x's. Of course, 2 x's and 2 negative x's combine to equal nothing. So now, when we go ahead and add all that up, we have 4x plus 2x is 6x. Subtracting 2 negative x's and adding 2 negative x's is nothing. Then we're left with our negative 2. And on the right-hand side, 2 of the negative x's minus 18. If you compare that to the left-hand side, we're left with 6 x's and a negative 2, and then 2 negative x's and a negative 18. So we have the same thing as what we have over here on the right. Now, when you're setting up this equation, you do not have to show this intermediate step right here. The only reason that I put it on here, rather than going from here straight to here, is to show you what happens when we are adding that 0 pair. A lot of you may have already realized that when you subtract 2 negative x's, what you're really doing is adding 2 positive x's. If we're subtracting 2 negative x's, we're really ending up adding 2 positive x's to our equation. So you probably could jump from right here to right here without having to show that step. Now, actually, in the same vein, what we really did with the 18, when we subtracted the 18, is we really added a 0 pair because we didn't really have 18. So we really added an 18 and then added a negative 18. And of course, that's equal to 0. And then when we simplify this now, we have 6x plus negative 2 equals 2 of the negative x's. Negative 18 and positive 18 cancel each other out, so we have plus negative 18. You may also have realized that subtracting 18 is the same thing as adding negative 18. Going back to the pictorial, I'm going to rewrite this. So I have 6 x's, 1, 2, 3, 4, 5, 6, and negative 2, and 2 negative x's, and a negative 18. And I'm going to take away negative 2 from each side. So this will become negative 16. Over on the right-hand side, I'm going to do the same thing, taking away a negative 2 and a negative 2. Let's do that. There we go. And I'll be left with 6 x's on the left-hand side equals 2 of the negative x's. And then if I had 18 negatives and I just took away 2 negatives, I'm left with 16 negatives. And you could again compare the pictures to the written notation on the right. The next step for the pictures is redraw this. And now I'm going to try to get rid of the two stars, or the two negative x's. I'm going to do that by adding two positive x's to each side. So two positive x's and then two positive x's. And here's what that would look like after I finished. So I now have 8. And these negative x's and positive x's are going to form 0 pairs that we can remove. And on the right hand side we'll do the same thing. We'll add two positive x's. Of course, we're adding two positive x's on either side. It's not going to change the equation because we know that 2x is equal to 2x. So that leaves us with 8x on the left-hand side. These two positive x's and these two negative x's cancel each other out. So we're left with 8x's is equal to negative 16. And on over here, we can redraw that and see that. 5, 6, 7, 8 is equal to negative 16. Well, if 8x's is equal to negative 16, 1x is equal to negative 2. You'll notice that once you get into more difficult equations, that it gets to be very complicated, and you really just have to take it step by step. For the check, I'm going to go up to the blue equation at the top and plug in negative 2 everywhere I see x. So if I have 4 x's, that would be 4 negative 2's, which would be negative 8. And then I want 2 of the negative x's. Well, if x is negative 2, negative x would be positive 2. So that would be positive 4, and I want to subtract positive 4. So subtracting positive 4 is really the same thing as adding negative 4. So that gives me negative 12 so far, and I'm adding 2 more negatives. So that's now negative 14 on the left-hand side. On the right-hand side, I have 2 negative x's, so that means 2 positive 2's, which would be 4. And then I'm wanting to subtract 18, which is, again, the same thing as adding negative 18. And 4 plus negative 18 is negative 14. So my check is negative 14 equals negative 14. And here is one last example. So on the left-hand side, we have 3x. We're trying to take away a whole big expression that's in the parentheses. So we have a negative x plus 4 in the parentheses. We want to take away 2 of those. So let's go ahead and draw that negative x plus 4. That would be the star and a 4. And of course we have to make that as a 0 pair because we don't have a star and a 4. And we want to do that twice, so I'm going to do that again. And now what we want to do is we want to take away the negative x plus 4 twice. So basically all this, we want to take this away. On the right-hand side, we just have an x and a negative 32. On the written side, we're going to write it all out. And because this is going to use the distributive property, to simplify the expression, I'm going to distribute the 2 to everything in the parentheses. Now be careful here because I am wanting to subtract all of this expression from 3x. So it might be helpful for you to think of this as all together because it all has to be subtracted. Now I'm going to add a 0 pair because I don't have that expression to take away. So I'm going to add this entire expression, 2 negative x plus 4. And I'm going to go ahead and put it back in the red parentheses. This is the entire expression that I just added. Well, I also have to add, if I'm adding 2 of negative x plus 4, I have to add 2 of the positive x and negative 4's. So I have to add the opposite of everything too to make sure that it's a 0 pair. So way over to the left, I'm going to add 2 of the opposite. So add 2 of the positive x's and 2 of the opposite of 4. So 2 negative 4's. That makes my 0 pair because this expression, 2 x's and 2 negative 4's, is the exact opposite of 2 negative x's and 2 positive 4's. That has a value of nothing. Now when I add all this up, I have 3 x's plus these 2 x's gives me 5 x's. And then I have the negative 4, but I have 2 of them, so 2 negative 4's would be the same thing as combining -8 with this. And all the part in the red parentheses is the part that I was actually subtracting. So the reason that I added this part right here is so that I could take it away up here. So this part right here, subtracting and then adding it back, cancels everything out. If I subtract, for example, let's say that this entire red expression right here was 3. If I subtracted 3 and then added 3, I'm doing nothing to my equation. So that entire part is now gone, and the right-hand side is x plus -32. So on the left-hand side, our pictorial method over here, I can simplify this, and we have 5x's, 2 -4's, which is the same thing as -8, and then an x and a -32. I think the next thing that I'm going to do is I'm going to take an x away from both sides. So let me show taking an x away from the left side and from the right side. And then over on the algebra portion, we're taking an x away from both sides. And of course, taking a -x is equal to a -x, or subtracting an x on the left is the same thing as subtracting an x on the right. So we're left with 4x plus -8 equals -32. Let me draw that out on the left. And then I think I'm going to take away the -8 from both sides. And when I take away -8 from -32, I'm left with -24. And then I'll do that over on the algebra portion, taking away -8, and then taking away -8. This part cancels out, adding a -8 and taking away a -8 cancels out. And then if we have a -32 and we're trying to take away 8 negatives, we just want to remove 8 of our negatives. Well, we have 8 negatives, so when we remove 8 negatives, we're left with 24 negatives. And now we're at the portion where we can just use our intuition to solve this. We have 4x's equals -24, so then x would have to equal -6. And what you're actually really doing here is you're actually really dividing by 4 on both sides. And 4 divided by 4 is equal to 1x. We just don't write that 1 in front of the x. And then -24 divided by 4 is equal to -6. To perform our check, I'm going to go up to the original blue equation. X was -6. So 3x would be 3 -6's, which is -18. And then this part, I'm going to do all the stuff in parentheses. I'm going to do all of this part first. So -x, that would be +6. +6 plus 4 is 10. 2 times 10 would be 20. Now I want to subtract 20 from -18. I want to take away 20 from -18. So if I want to take away 20 here, that is the same thing as adding -20. So altogether on the left-hand side, we now have -38. And on the right-hand side, we're going to have -6 plus -32, which is also -38. Our check is -38 equals -38. Please don't worry if you're still struggling with connecting the pictorial method that we're doing on the left with the written notation that I'm doing on the right. When you get into algebra, you'll have a lot more experience with much simpler equations before you jump into doing written notation with ones that are very difficult like these. Really, the purpose of this lesson is just to allow you to see the connection between this pictorial method here with the more standard version that you're going to see later on with algebra. It's really just a preview for you. I certainly would not expect you to be able to do this method without being able to do this method at the same time. And even then, this method right here is going to be really challenging for you to do at this point. But I do hope you can see the connection between what we've been doing, even translating things to pictures, to what we are doing here on the right-hand side.